to this computer. All right, so I think we're on recording now. The recording is on. So, can you hear me okay?
Yes.
Right. So, how are you, Martin? Are you still on your home quarantine right now?
Yes.
Right. So, we are going to have our Algebra 2 tutorial discussion this afternoon. Do you have a worship for our session for today, or you have a certain
Oh no.
specific topic that you want us to discuss?
Um, I'm still kind of confused on exponential functions.
All right. Okay. All right. So we're going to discuss about the exponential function. Okay. Let me show you the sketch book, and so we can work from there. Oops. Okay. Um, share my screen. Okay. Can you see my screen now? It's all white.
Yes.
Okay. So let's talk about exponential function. Um, okay, exponential function. So exponential function has a general format or syntax. By writing f of x is a function of base b to the exponent x or raised to x. So we have a superscript here, and we call this as exponent. So basically, when we have an exponential function, we have an exponent. We have the variable in the exponent. So not just to have an exponent, but a variable in the exponent, especially when we take x as a variable involved in the exponent. Say for example, you have, okay, example. Let me check your view there. How can you see my, all right. So for example, number one, let's say you have y is equal to the base, let's say 12 raised to x. This is an example of an exponential equation or exponential function. Your y is an f of x, and your base is 12, and the exponent is x. As you can see, we have here x variable that can be seen or located in the exponent part. Okay, the exponent is the superscript. Okay? Hello, Martin. On the recording. Okay, so the recording is on. All right. So this is an example of exponential equation, exponential function. And we will look at the different graph of function, specifically the exponential function. So let me stop this sketchbook and share with you this tool, graphing tool, so we can see the graph of an exponential function. So you can see here, let's say we have a simple exponential equation. We have f of x or y is equal to 2 raised to, let's say, raised to x. So raised to x. What is it? Raised to let's say x. So can you see that we have y is equal to base 2 raised to x. And so this is the graph of that. Okay. Let's take another example. Let's say y is equal to base 2 raised to, let's take x plus, let's say plus 4. Oops, sorry. X plus 4. Okay. So can you see this purple one?
Yes.
Right. So this is another example of the graph of this function, exponential function. Let's take another graph. Let's just copy this graph above and do some modification. Let's take the x exponent as negative exponent. So let's take this negative x. Can you see the black one? This is the
Yes.
graph when we take the x as the negative. Another example. Let's copy again the original exponential function above. Y is equal to 2 raised to x, and let's add let's add, let's say 5. So we can see that the red one is the graph of this. So what we can observe here, say for example, let's take the first one. The first one here, number 1 and number 2. So let me see how to there you go. I can hide this graph of number 3 and number 4, just for us to compare number 1 and number 2. So as you can observe, when we have y is equal to 2 raised to x, we have this blue graph here. So by having this original graph, we can say that the easiest way to figure out the graph of a given, okay, the easiest way, let's just take this one. The easiest way to figure out the graph of a given exponential function is by taking or substituting the value of 0 to the x. So if here we have, if we substitute 0 for the x, we have 2 raised to 0, right? Hello, Martin, are you there?
Yes.
Okay.
Yes.
So when we have 2 raised to 0, what is that, or where is that equal to? What is the equivalent of 2 raised to 0? When you have 2 raised to 0, if you
It
can
is
still, if you can still remember the exponential property or the properties of exponents, when we raise a certain real number to 0, where is that equal to? What is the equivalent of that?
1.
1, exactly. So as you can see there, we can figure out the graph of exponential function by substituting 0 to x to make the output or the value of y to be equal to 1. So as you can see in our let me add here, when x is equal to 0, let's use the ordered pair. When x is equal to 0, y is equal to 1. Okay?
Yes.
Okay, and so we can see that there in our graph, the 1 and 0. So for sure, the graph will pass through that point. So we can just figure that out. Another thing, another ordered pair that we can do is when we substitute x is equal to 1, because that's easy to compute. When we have x is equal to 1, what would be our y? Okay, we're talking about this expression or equation in number 1. When we take x equal to 1, what would be our y?
Uh, it will be a 7. Or wait, no. Wait, oh, hold on.
We have 2 raised to 1. What is that?
Oh, then it's 2.
Then it's 2. So y is equal to 2. Okay? So there you go. As you can see, the point is actually, of course, the point is lies on in the graph. And we just can figure out, if we do not know the graph of this equation yet, we can just figure out that this equation passed through these points. Right?
Yes.
So we have 0 and 1, and 1 and 2. And so by just looking at the graph and like substituting the value of x, where it will become, the exponent will become 0, or the exponent will become 1, will give us the easiest way to compute the y. So we have the x as the input and the y as the output. So we can have the 2 ordered pairs. And in this case, we have 0 and 1 and 1 and 2. And so, of course, we can predict that the graph will pass through to this points. Again, since we are talking about here exponential function, the graph about exponential function is not a linear, it's not straight line, because we're not talking about linear function in this case. So it will become a curved one. So it will pass through to these 2 points. Okay.
Yes.
Now another thing that we have to like figure out when we talk about the graph of an exponential function is the asymptote, or the line that the graph is approaching to. So say for example, what will happen to the output if we take the input x very high or very large number? So say let's say we substitute the very large or very small number for x. What could be the very small possible value of x?
Um,
It's a negative number, right?
yes.
And when we take the negative exponent, when we take the negative of the exponent of a given number, let's say here we have 2, okay? 2 raised to x. When we take the negative of x, it will become the reciprocal, right? The negative exponent will give us the reciprocal, the 1 over of that base. So we have 1/2, right?
Yes.
And so when we have 1/2 raised to a given number, of course, the exponent will become positive because we already reciprocate the base. So that is 1/2. Okay, let me share my sketchbook again. So here, let's say we have, when we have 2 raised to x, and when we take the x equal to negative, okay, negative number. Okay, negative number. Let's say we have 2 raised to negative, let's say negative 3. What will happen? It will become 1/2 raised to 3. It will become positive now, or simply we have 1 over 2 raised to 3. So we have a positive exponent now in the denominator, all right?
Yes.
And it will become 8. So, and then like when you increase the numerical value in the negative, or the lowest to the left, the smallest possible value of x, the denominator, oops, I don't put space here. Let me try. Okay, the denominator becomes larger and larger and larger as we substitute the smallest possible value of x is negative. It will become 1 over 2 raised to x. It's positive. As you increase x, the whole denominator will increase. And so we have like 1 over in positive infinity, right?
Yes.
And when we divide 1 with a very, very large number, it will approach to 0. Like when you divide 1 with an infinite number, if you divide 1 by 2, it will become 1/2. Divide by 4, it will become 1/4. Divided by a large number, it will become like a 0.00000, a very small number. It will actually approach to 0. Okay?
Yes.
Now, going back to our original exponential function, y is equal to 2 raised to x. When we evaluate this function by substituting x approaching to the negative, okay, negative infinity, the smallest number that we could have, the y will go to 0, will approach 0, right?
Yes.
Therefore, we can figure out in our function, we can figure out that as in this point, as we go to the left, this is the negative part of the x, right? Going to the leftmost. Okay, so as we go to the left, let me show the graph. There you go. As we move on to the left, that is the negative part of x. As we move to the leftmost, y becomes 0. Therefore, the y, let me uh, have here a y is equal to 0. Y is equal to 0. Okay. So there is the purple one. Can you see this one?
Yes.
This is the line that where this graph is asymptotic. So we call this as a asymptotic line or horizontal asymptote, because this is horizontal in the first place. So now we can see that the graph will be approaching to that line, but it will not touch. In this graph, it seems like it touched that line, but in reality, it will not touch that line. There will be no value of x that would become equal to, y will be equal to 0. Okay, because why? Because we cannot have any value of x that would make y is equal to 0. Can you think of any exponent that would make y would become 0? Like 2 raised to negative 1,000. It's still, there is a value. It's not equal to 0. But then the value of y approaches to that y is equal to 0. So we have here the asymptotic or asymptotes. We have the horizontal asymptote line. So therefore, we can like figure out that the graph would be passing through these 2 points, and it would be like asymptotic to this line. It's a curve to this line. So as you can see, I'm going to zoom it in. So here, I'm zooming it in, I'm zooming it in, and you can see that while I'm zooming it in, there we cannot find that the graph is actually touching the line. It's going closer and closer. Can you see that? It's growing closer and closer.
Yes.
I'm moving it to the left, closer and closer, but it will never touch that line because we call that this asymptote. Now, there are 3 things for us to figure out. For us to figure out the graph of a given function, exponential function specifically. To find out the 2 points where we can evaluate the graph, and to look at the asymptotic line, okay, where y will become, where the curve will be asymptotic to. Okay. So do you somehow understand the graph or like figure out the graph of this exponential function?
Yes.
Okay, so now as another thing, if you're going to like take the negative of the base. So let's just write y is equal to, again, we have 2 raised to x, right? Originally, we have 2 raised to x. But what if we're going to make the expression at the left, like we have here, something like this. It's negative. So we have the negative of the expression at the right. So you see at the graph here, the difference is like the graph of the original graph flipped downward. Can you see that?
Yes.
And so those are the some modification that you will see when we try to make the parts of the exponential equation as negative. It will just like flipping horizontally or vertically. Another way, let's say what will happen if we take exponent as negative. Can you see that? It
Yes.
will flip like horizontally. So when you take the negative of the exponent, it flips horizontally. So it's like flipping the rightward or leftward, horizontal. But when we take the negative of the whole thing, like the base, it will flip vertically. So another thing that you will like notice here, when we take the exponent x and subtract a real number to that or add a real number to that, let's see what will happen. So let's subtract in the exponent here. No, not subtract, but let's just add 4. Let us just add 4 here. Can you see this one? We have y is equal to 2 raised to x, and we add 4 to the exponent. And the graph is this. What can you say about the graph? Yeah.
It's more to the left.
Yeah, it seems
It's
that
not.
it moves to the left. It shifts to the left, right?
Yes.
Okay, so let's just increase 4. Let's add 10. So it's moving farther and farther to the original, moving to the left. You can notice that. Let's take 20. See? Okay, let's take 30. Okay. You can see the distance of its shifting from the original to the left.
Yes.
Okay. So of course, if we subtract instead of add, it will just move to the right. Let's say we have net minus 4. Oh, sorry, we're dealing with exponent x minus 4. Oops. Sorry again. Minus 4. Okay. Let me just change the plus sign there. Okay, we have plus 3. A while ago we have plus 4. And let's just make it minus. So as you can see, the graph shifted to the right instead of to the left.
Yes.
Can you notice that?
Yes.
And of course, when we make it 13, it will move to the right farther than the original. So we call this as like a shifting of graph, like that, to the left or to the right. Okay, so that would happen when we change or add or subtract to the exponent, to the x component. Okay, what will happen if we take the original graph and let's say add to that whole expression of exponent. We have originally 2 raised to x, right?
Yes.
And let's say we add 5. Let's say we add 5. What would be the graph of that look like? So let's show it. So as you can see, the graph of that shifted above.
Wait,
So it moves vertically.
oh,
Can you see
yes.
that? And when we make it 10, it will move farther to the above of the original line. When we make it 30, it will move more units to the original graph. Of course, when we make it minus, when we make it subtraction, let's say this is plus 5. When we make it minus, it will go to the down to the below of the original, below the original. Okay, and let's say this is minus 10. Okay, it's going deeper and deeper below the original graph. Minus 20. Can you see that?
Yes.
Okay. So when you change the exponent, let's say adding and subtracting in the exponent where x is located, the graph shifted from left to right. So you can see there, when we now add or subtract to the whole expression, actually, this is another way. Can you see this one, minus 20? We actually like adding or subtracting to the y. We can transpose this negative 20 to the left side by writing plus 20. This is the same as plus 20. Okay?
Yes.
So therefore, you can see when you are like adding or subtracting to the y, it shifted to the vertically, to the uh, uh, lower of the original and to the upper part of the original. So, but anyway, the usual way of doing that is like adding to the uh, right side instead of to the left side. But you can see the shift is vertical. There is a vertical shift above the original or below the original. So this is important thing to notice because most of the time the exams goes like, what will be the graph when you modify certain parts of the exponential function or exponential equation? Okay? Do you have any questions so far to this graph of function? I mean graph of exponential function.
Oh, no.
Right. So we have the format. We have like how to write an exponential function. We have how to graph. What would be the graph look like? When we are modifying parts of the graph, what would be the changes that would happen in the graph? So the next part is solving the exponential function or evaluating exponential function. Basically, we are used to solve for the exponential function. Say, for example, what would be the value of x? We're finding the value of x. Okay?
Oh, yes.
So we will go there, solving or evaluating. That's different thing, evaluating and solving a exponential function. And we still have some 7 minutes. We will go to evaluating a function. Is that okay with you?
Oh, yeah.
Right now, do you have any specific question regarding this exponential function so far?
Right now, I understand everything so far.
Wow, that's great. Okay, you know how to evaluate function. I mean, yeah, that's what I mean. You know how to evaluate function. Are you familiar with evaluating function?
I'm not sure.
All right. So when you were asked to evaluate function, you simply asked to find y given the certain value of x. That's simple. I know you can do that. But I want you to understand that when you are told to evaluate a function, the question actually wants you to find the value of y when you have the given value of x. That's very simple. Let me share with you this sketchbook. Okay, let's have another layer, new layer for this. We will go to evaluating exponential function. Evaluate. Okay, evaluating exponential function. Example, number one, the exponential equation could be y is equal to, let's say, 2 raised to x. This is our exponential equation. And evaluate this function. By the way, the usual way of presenting it is not y, but actually f of x is equal to 2 raised to x. So when you are asked to evaluate this function, you actually given with the value of x. Let's say what is f of let's say 2. This is the usual way of asking. What is f of 2? Mean to say, what would be the value of y when you substitute x is equal to 2? That is simply y is equal to, this is simply f of x is equal to 2 raised to x, and f of 2 is equal to 2 raised to 2. And f of 2 basically is equal to 4. And finally, you have, when x is equal to 2, you have y is equal to 4. That's the simplest way of understanding the evaluation. So you have the coordinate or point coordinate order pair 2 and 4. Okay, that's how the evaluate function. I know you know that. I know you can do this, right?
Yes.
Okay, so another example. So let me ask you, what is f of 0?
F of 0.
Yeah. What is f of 0?
When you plug it into 2 of x or just
Well, another way of asking this is, what would be the value of y when x is equal to 0?
A 1.
1, exactly.
Or
So you can actually solve that in your mind, right? But in order for you to have a proper way of solving that, I mean, writing is always the best way, so you can reduce the typographical or simple errors. So f of 0 is 2 raised to 0, and f of 0 is equal to 1. Okay? So y is equal to 1. And therefore, we can conclude when x is equal to 0, y is equal to 1. And we have an ordered pair of 1 and 0. All right? So, can you still hear me okay there?
hello?
Hello, Martin?
Hello? Hello? Hello?
Hello, Martin. Can you hear me okay?
Yes.
Okay. So, do you understand the evaluating of this function?
Yes.
So basically, that's the evaluating of exponential function. So I will just give you an assignment for this. I'll send you the link. And if you have no more question, this is until here the class is over. So thank you so much. You have any
Yeah, thank you.
question so far?
Oh, no.
All right, then that's it. Thank you so much, Martin.
Thank you.
Bye.